Question number 7. Match the function with the graph that best describes the situation. The height of an animal is a function of time. So we are given here a real life scenario or a real life occurrence wherein we have to model the graph of the height of an animal as a function of time. So basically this is going to be a height versus time graph. So let us say this is your time, which is in years, because animals, of course, they grow year by year, which is similar to humans actually. So our time here is years. And our age here is the height of the animal as depicted by the time. So we have height maybe in, let's say, centimeters. Well, it depends actually on the animal we are talking about, but for purposes of considering those animals which are short, such as the cats or dogs, as compared to elephants or giraffes, then we just get a general depiction, which is a measurement of centimeter units. So basically the animal, let's say a cat, okay? So a cat starts growing after birth, of course, same as humans. So it will somehow have, let's say, a linear or an increasing pattern for the growth of the animal year by year. Let's say it's growing by 10 centimeters per year. So at a certain time t, okay, and let's depict that with a vertical line. So let's depict that height, wherein the height growth is the climax, or when the animal stops growing anymore. So of course, when the animal stops growing anymore, it will just give you a certain representation which is constant. So it would be somehow like that. And so it will be somewhat like this. So therefore, our graph, which is closely similar to what we drew, is letter A. So our answer is letter A. Why are we so sure that it's letter A? Because at this point here, on this graph, that's the time when the x in time, the x is equal to time when the animal stopped growing anymore. So we have a constant height of the animal. It cannot, of course, get shorter because it attained its maximum height. Well, some animals do get shorter, but because of physical disasters, like physical deformities, for example, the animal become, for example, okay, if the animal got amputated in the leg, then it will get shorter than the maximum height that it attained. But it can't be like this for letter B, because it would be ridiculous to see an animal having a height which attained its maximum at this point, and then it loses it. It's like it loses it, and then it regressed. It regressed back to 0 to where it belonged. It's ridiculous. And of course, it's not also letter C. It couldn't be letter C, because assuming this, and this is a power function. So a power function increases with no bound. We are not, if we are given a limit here, if we're given a certain boundary here, like in this case, then we can consider this graph. But we don't have a boundary wherein the growth would stop. It's simply, the graph simply goes increasingly on a power function. So that is not an option. And letter D is also not an option, because growth is from nothing or from a certain very minimal height to a certain maximum height. So this one is a representation for maximum, and then it regressed to 0. So this is not also possible. So our answer is letter A.